All right. Hello, everybody. It is Friday, last day of the third quarter. And what I wanted to go over today was our warm up from one of our uh, new units that we're going to go into in Unit 14 called Factorial. So please give that a shot in Coding Bat. It's in the Recursion 1 folder called Factorial. A couple announcements. If you need help, get in touch with me. I realize we're kind of doing a one-way thing here where I'm pushing out videos and we're not doing live classes. But if you need help, some of you have already reached out to me and you want to talk about um, some code that you're confused on, or you need more support with, or you just want to touch base on some things, just please let me know and I will set up a call, a video call or a phone call or something like that. Q3 grades are going to be locked today. Please make sure you have your coding bats completed. That's basically the last thing I'm going to be putting into the grade book. So all of those are listed in the description part of the Aries assignment. So that's going to be locked today. The third quarter officially ends today, right? We were technically supposed to be doing finals today. I'm going to review the assignment and quiz schedule, and then I'll intro Unit 14. And then when we get back from um, the spring break, I will talk about the second half of it. So I'm going to intro recursion today. I'll talk about 2D arrays when we get back, and then we'll be between the two of those things, we'll be able to then do um, more advanced things like searching and sorting. All right, and then the 11's activity 7 through 9, I covered code for that, so hopefully you're up to speed on that. If you have issues with the game itself, let me know, and we can go through more examples with that, more code walkthroughs with it if needed. And then 14 will be the recursion stuff. All right, so assignment and quiz schedule. This has been updated. I canceled the final exam for Q3. We're not doing that. Bunch of stuff that's due on the 13th when you get back from spring break. So if you have hardships with that, I don't know that many people are traveling for spring break, but if you just want to relax and decompress and not do anything and you can't get any of those assignments done, please let me know. This has been around for a while and we've been talking about Unit 12 was something that we were doing before we even closed. So hopefully that is not a problem for you. Um, and then we'll work through this. In fact, actually, because I'm not going to be covering 2D arrays, let me make this thing further out. Let's call this, I don't know, let's say the 15th for now, so it's not due when we get back, because I haven't formally covered 2D arrays. But if you want to work on it, please go ahead. All right, so that is yeah. I will redo this. This doesn't seem to make a whole lot of sense with having all these things due the 13th. I think we were intending to be back to school on the 13th. Obviously, that's not going to happen until at least the end of the month, and who knows how much longer after that. All right. Yeah, so the warm up. So I'm going to cover that now, and then I'll formally introduce the recursion stuff. Okay, so this is kind of like the warm ups. I tend to throw new things at you. Many of you have heard of recursion, maybe don't know quite what it is, but I'll explain it through an example. This is probably the most traditional example for implementing recursion, implementing a factorial. And for those who forgotten what factorials are, you basically take whatever the number is you're implementing the factorial on, and you multiply together all of the values from the number n all the way down to 1. So you multiply that times your number decremented by 1 times your number decremented by 2 all the way down to 1. All right, so this is prime for doing a factorial type operation on it because you can do a function over and over again. All right, so that's basically what factorials do. They will take some base condition and some base calculation, and they will implement that over and over again through a call of the method itself. Okay, so I've got this method called factorial, and then you see down in here I'm calling this method factorial again. Okay, well this is the same method here. So how does that work? Well, it does some operations on the computer hardware, mainly called the stack, where it pushes things onto the stack and then it pops some things back off of the stack when you are doing what's called unwinding the stack for in a factorial operation. All right, so I'm going to go through some diagrams on that to show you pictorially how that might work. And some people find it helpful, other people don't, and they will try to do this in their head. This one is one you can do with in your head, not too difficult. It's not too difficult to do, but there's some factorial pieces of code that are get a little bit complicated. So you'll want some mechanism to be able to track through it. So this part right here is called the base case. So the base case is basically the way that you terminate the method or terminate the recursive call. So you have to have something like that, otherwise it will never end and you'll just end up crashing your computer because it'll just keep calling itself over and over again forever. So you need some base case, so make sure you have that. And in that case, you're going to just end up returning some value or some calculated value, and then it will do what's called unwinding. And again, I'll talk about that in more detail. Otherwise, you are going to do some sort of operation where part of that operation will be a recursive call to the method itself. Okay, so here is the recursive call. It's calling the same method again. And so what it would do is it's going to take this value in here, and whatever we're taking the factorial of, say it's going to be 4, for example. Well, the factorial of 4 would be 4 times 3 times 2 times 1, right? So I would check to see in my base case whether or not the input value, in this case 4, is less than or equal to 1. Well, it's not. So I go into this line in here. Okay, so this line in here then says I'm going to return the value n, which would be 4, times the factorial of n minus 1, which would be 3. Right? So I'm going to call the method again with the value 3. Okay, so I've got the 4 here. I'm multiplying it by the factorial of 3, and then 3 will come back in here and it will check to see if it's less than or equal to 1. It's not. It will do then this calculation again. So it will keep doing this over and over again where I'm subtracting 1 each time from that value. So it started at 4, then it went to 3, then it will go to 2, then it will go to 1. And at some point when it hits that base case, so in this case it's going to be when it's 1, then I'm going to return a 1. Well, when it returns the 1, then it starts doing what's called unwinding. And so that's basically how it ends, and it does the accumulation of all of those operations that it was doing while it was doing this recursive call. Okay, so to evaluate this, we would say, well, this is going to take 4 times 3, and then 3 times 2, and then 2 times 1, and then it's done. Right? So 4 times 3 times 2 times 1 will end up being the final value when we finish this recursive routine. All right, so that I kind of talked my way through it, and you can, I think intuitively, you can kind of see what's happening there. But again, it's not super clean in terms of the thought process to walk through it. So I'll go through, like I said, an example of how you could actually diagram this, and it's a little bit more systematic to walk through than if you're just trying to kind of mind bend this thing. Because like I said, this is probably the simplest one. It gets harder than this as you get more complex functionality. Okay, so let's take a look at some of the slides that came with this unit. So if you download the unit from the classroom, you're going to get a couple sets of slides. All right, so recursion is a routine that you have successive calls to a method, and it's calling itself. So recursion occurs when a method calls itself. Right, so that's the basic definition. You need to have some base case. How you have to make it stop at some point. Okay, if you don't make it stop, then you are going to run the routine forever, or until the hardware tells you can't run it anymore, and that's called a stack overflow. So it just keeps putting stuff onto the hardware memory, and the memory is going to overload at some point, and it's going to get it's going to probably do some sort of security concern in the OS and step on some pieces of memory that it couldn't, and it will just it'll crash your computer. Okay, so you have to make sure you have a base case that will stop it. And that's what this thing is, a stop condition or a base case. So the calls will continue until the stop condition is met. So here's another one here. I come in to this routine with an integer, we print something out, and if it's as long as it's less than 5, then we call the routine again with an increment on the number. So with factorial, we decremented it and multiplied some things, right? So this thing is going to print something out and increment the number and do it 5 times until x is equal to 5 in this case, right? When x is equal to 5, then it's done, and it will do what's called unwinding again. So it'll stop the calls to this routine. All right, so that's what that would do in that output. All right, more examples here. You can see you have to have some sort of condition. So typically it's an if condition or some sort of loop or something like that. And then you have to have your recursive call when you run it. You can implement everything that you could implement with recursion with a loop, like this while loop. And so this loop is effectively implementing the same thing as a recursive call. So in your recursive call, like I said, you need to have some sort of condition, some sort of looping structure or some condition that just checks something. And then you have to have some way of calling the routine again. But you could do the same type of thing with a loop. Okay, so why do we use recursion? Well, it's more it generates more compact code. So if you're trying to save code space, you can do that. A recursive call will do that for you. And then it's a little bit cleaner in terms of the code reuse. It will run typically faster if you're pushing things onto a memory stack. Stacks are usually faster than the external memory in a computer. But like I said, we'll talk about how it gets pushed onto the stack and popped off in a bit. These slides will talk about it. An activation record for that method call is put on the stack with spots for the parameters arguments that are being passed. So you can just think of stack as being a piece of memory, and as you are making calls to a method, there's a bunch of stuff that's put on that memory that saves the state as you're kind of sequencing through a program. If you call a method over and over again, like you do in recursion, it's going to keep pushing things onto the stack. So this is the issue. If you don't have a termination condition, it will continue to do this until you finally fill the stack up, and it will crash your computer. So at some point you will unwind. If you have a proper termination condition, it will reduce the stack by 1 each time as it moves back through the calling sequence. Okay, so I'm saying a lot of stuff that maybe doesn't make a lot of sense, but I will diagram this next time, and you'll see that it's pretty easy to trace through if you have a systematic way to do it. All right, more examples. Make sure you have a base case so that you can stop your recursion. That's probably the biggest error that I see usually when people are trying to implement things, is that they forget to put the base case down. Yeah, and so you can trace through it, and I will give you some examples on how to trace through it. So don't worry if you're really lost on how to figure out if something is working or not. Okay, so a bunch of examples there you can go through. All right. As far as our logistics for the rest of the term goes, we're going to be kicking off the fourth quarter when you guys get back from the break. And I'll give you more information on how we're going to do things like assessments and stuff like that, because we probably will have a few quizzes along the way. I don't know yet about any formal exams, but I probably will do a few quizzes that will be like Illuminate and things like that. So just stay tuned for that, and I'll give you more information. All right, everybody, have a good week, and I will talk to you again on the 13th.